And today we're gonna do coding.
Yeah.
That's my dad.
Yeah,
He's gonna
okay.
be the teacher.
Mr. Ray, how are you? Mr. Ryan, how are you? Good?
We're talking about the target.
Yeah, today given a number, okay, so let's say given a number 5. And we want to
Okay.
convert it to 9. How do we do it? Every time.
We add 4.
Nice try, okay? So you can do what? You can
5 and 9.
no. You can plus 1, or you can times 2. Sorry.
None of them works.
No, you can minus 1 or you can times 2. Right? Wait.
Are you kidding me?
Wait.
That make no sense.
Minus
But
1 and multiply 2.
we
Yes.
like it.
Yes. You can minus 1 or you can times 2, multiply 2.
That doesn't make any sense.
So look, how can you...
You times 2 and minus 1.
Yes. So you need a 2, right? Okay, let's try another number. 26 to 48. How many operations do you need?
You add 22. 26 to 48.
Yeah?
Minus 2 and times 2.
Well done. Minus 1, and then times 2. You need a 3 operation. Yeah? Does it make sense?
Oh, yeah.
Okay.
26 minus 2 equals 24 times 2.
Well done. Because you can choose to minus 1. And you need 2. And it becomes 24 and then times 2. Well done, Ryan. You got it, yeah? Yeah? Does it make sense?
Yeah.
Okay. So given the number star, and then can you write the algorithm to tell me how the minimum number of operations in order to change from the start to the end? Oh, any thoughts? How can we solve this problem? Okay, so can you tell me that if the target is smaller than the star, what happens? If like we want to convert from 10 to 5, so how can we do this?
All we need to do is minus 1.
Always
minus 1.
Yeah, that's wait, Eric, what did I say about not doing that? Yeah, that's right. If the target is smaller than the star,
all we need to do is minus.
we can't do this, yeah, right?
Yeah.
Okay, so I give you the hint. What? I give you the hint.
What?
If the target is smaller than the star, we can only minimum the difference, subtract the difference.
So this is subtract and this makes it smaller, this makes it bigger.
That's right, yes.
Yay!
Okay, so look, if we want to convert 44a to 26,
it has 22 difference.
yeah, I know. So look, if we consider in the opposite, if we converting the n to the star, if we reverse the direction, if it's an even number, if it's an odd number, we subtract 1, right?
Oh yeah!
No, we add 1, or we subtract 1. We add 1, right? Because the opposite, we add 1 to 10. And if it's even number, we what? We divide it by 2, alright? Yeah?
Yeah.
So 48 is an even number, so what do we do?
We divide it by 2.
Okay, 24. Look, now 24 is smaller than 26, so what should we do?
Add 1.
Add 1. But we don't need to, it's already smaller, so we just calculate the difference, right? Yeah? Just add it. That would be 2. Alright? Yeah? Can we do this? Does it make sense? So we reverse the operation. Define f star, s for star, e for end. Okay?
Column.
If end is smaller or equals star, what should we return? Return what?
If it's smaller.
Yeah. For 10, if we want to converting to 5, we want to start from 10 converting to 5. What should we?
We just do s e minus s. No, s minus e.
Well done.
Yeah.
Okay, then if e is N1. What does it mean? N1. What does it mean?
E and 1, and 1.
N1. What does it mean?
Oh, is E and 1.
What does it mean? It's an odd number or even number?
Even number. Or
Odd.
even. Odd. Yeah. Odd.
N1.
Odd.
If it's 1, then it's odd number. So this is odd number. So if it's an odd number, what should we do?
We show.
Look at let's
Add 1.
add 1. We're done. So return. If we're doing the recursive, 1 plus F.
E.
S and E what? E what?
E.
You just said it.
Add 1.
Yeah. And if it's even number, what should we do?
We
Return.
show half it.
Yeah, so
Divide
1
by 2.
plus F S E
Divided by 2.
divided by 2. Yeah. So let's recursion. So how many recursions are there? How many recursions are there? Can you tell me? How many recursions are
I'm
there?
calling it still.
Okay.
Yeah. How many recursions? Can you tell me how
I
many?
can't see.
Yeah.
No,
How
wait,
many-
please.
How many recursions?
2.
2. Yeah. Here.
Yeah.
What's the term
yeah,
complexity?
Babies.
What's the term complexity?
Oh,
It's hard, yeah?
O-N.
No, because every time we halven it. And then if it is in the case,
O-1.
oh, log n, yeah, roughly log n, roughly.
O-N again?
N is the difference, okay? But if it's smaller, then we can directly return it. That will be O1, right? But if this number is always, right, always bigger, and then always the even number, then we can always divide it by 2, right? Okay? So we can do this iterate, not using the recursion. This is like recursion, calling the function itself. But the recursion, the good advantage of a recursion is what? We can focus trying to solve one situation at a time. And then if this is all number, we can turn it to another problem, right? Alright? Calling itself to solve it. Yeah? If it's all number, if it's even number. Until we know if E is smaller than S, because we already know it's S minus E, right? Yes? Okay. So let's do it in recursion. So with the not the recursion, sorry. So we have to define the answer. Answer at the beginning equals what?
0.
Okay. So while, because while if the S is smaller or equals N, right?
Column.
Is it smaller or equals that? If it's N is smaller than, when the star is smaller than N.
Column.
Star is smaller than N. No.
Column.
Not equal, star column. Okay, so if the star is smaller than the N, what does it mean? If what?
The
And E.
If E is
and
N
1.
1, this is, what does it mean? If E N 1, what does it mean?
The N.
Is the,
it is an odd number.
if N is odd number, so,
yeah, that's
so
what
then
it means.
if N is odd number, then we need to do what? E plus or what?
Plus equals
1.
1.
Because if it's odd number, we can only add 1, right?
Else.
Look at Eric, 5 to 9.
Else.
If
else,
N is
else,
odd number,
else.
yeah, we add 1, yeah? 9 will become 10, right? Yeah? Else, what's else here? It's a odd number. or
And
even
you-
number.
Divide by equals 2.
Yeah.
And divide by equals 2.
And then we have this answer 1.
Answer plus equals 1.
Because we already make 1. And then when this ends, when the breaks, when the while loop ends, what does it mean? It means that S is bigger or equal than N, right? Yeah? So return what?
Return.
Answer.
Plus S
And here is
minus E.
S minus E. Well done. Yeah. Right? Because Y is after the while loop, this is S become bigger or equal than n, then we need to add the difference, right? Look, remember 26 to what? 48, right? Okay? So when this when this is 48, first of all, you need to divide it by 2, which is 24, right? Now the star is bigger than the n, right? Yeah? What does it mean? It takes 26 minus 24, 2 operation to subtract 26 to 24, right? Yeah, that's what it means here. S minus E is 26 minus 24, right? The answer is 1, right? So it is 3 operations. Does it make sense? Yeah? Does it make sense?
Not so fast.
No, does it make sense?
Yeah.
Okay, what's here?
Well, answer plus equal 1.
Okay.
Easy. Simple.
We just
Yeah.
look in.
Okay, that's it for today. Thank you. It's a bit easy today, yeah? It's a math problem, okay?
Beep beep.
Bye bye. See you tomorrow.
Bye, baby.
See you tomorrow.